All right, hello everybody. These notes are going to be on moisture, and by moisture we're talking about relative humidity and dew point temperatures. Now, where does the moisture in our atmosphere come from? Remember, 70% of our planet is covered in water. The biggest body of water there is the ocean. It's not the only source. We do have lakes, rivers, soils, and plants, which do contribute moisture to the atmosphere. But the majority of that is coming from evaporation of the oceans. So the term relative humidity is a comparison of the amount of water vapor the air is holding to the amount of water vapor that the air can actually hold. Warm air can hold more water vapor than cold air. And the reason for this is because when air is heated and becomes warm, it expands. And if you look at this picture, notes on your notes, because I found this a little late. If we start off at a temperature of 10 degrees, the volume of the air is 100% full. So we would say that's 100% relative humidity. But as we warm it up to 20 degrees Celsius, the volume of the air parcel itself has expanded, but the amount of water vapor has remained the same. So the relative humidity has decreased. As the temperature continues to rise, the volume keeps getting bigger, but the amount of water vapor hasn't changed. So the relative humidity has gone down. So what I would like you to do is just write on the bottom of this page that since warm air expands, it can hold more water, which lowers its relative humidity. So please add that to your notes before moving on. All right, the instrument that we use to measure relative humidity is a really fun instrument called a sling psychrometer. You guys are going to get a kick out of using it in class. It's basically two thermometers attached to a handle that you spin around. One of those thermometers is called the dry bulb thermometer, and this measures air temperature. There is nothing attached to it. It is a normal temperature, but we call it the dry bulb. The other thermometer, and it's not really shown on here very well, it's called the wet bulb thermometer. Usually there's like a piece of cloth attached to the bottom of the other thermometer, and you get that wet. And when you're spinning around, the water evaporates off of it. So the wet bulb thermometer measures the temperature after evaporation has happened. If you remember from our changes in state notes, evaporation is a cooling process. So the wet bulb thermometer will actually go down when you spin the sling psychrometer. So you're going to get a difference in temperatures between the dry bulb and the wet bulb. The amount of cooling depends on the rate of evaporation. If you have a big difference in temperatures between the dry bulb and the wet bulb, that means a lot of evaporation has taken place and the air is pretty dry, because if it's dry, there's not a lot of water vapor, which means there's more room for that water vapor to go. The smaller the difference between the dry bulb and the wet bulb, the more humid the air temperature. I did skip over D where it says how to use the reference table to determine relative humidity. We are going to do that in class, so just skip down to E under those tables. All right, the next thing that we talk about when we talk about moisture is the dew point. This is an actual temperature that the air cools, and once it reaches its dew point, the air is saturated. That means it is full of water vapor. Cold air holds less water vapor than warm air, so when the air is colder, the dew point's usually on the lower side. And we still use a sling psychrometer to measure dew point. And we'll go over how to do that in class. And I'm skipping over C, how to use the reference table to determine dew point, and going down to D. Once the dew point temperature is reached, condensation happens. So you have to reach dew point in order to form a cloud. And the closer the dew point is to the air temperature, the more humid the air. And we are going to go over all of this in class. And I'll leave you with this video that cracks me up all the time, because the jury is out on what this animal actually is. I'm pretty sure it's a bunny, but it's so poofy it's hard to tell. Other people think it might be a cat or a dog. I'd love to hear your opinions on it. Regardless, some of us who have thick hair have experienced the frizz like this. So make sure you've answered the last few questions and come to class ready to do some dew point relative humidity conversions.